to our on-demand session. I'm Yuming Liu, Principal Product Manager from Azure Storage team. And today, I'm joined by my colleague, Adarsh.
Hey, Yumin, thanks for having me. I'm excited to show you guys all about Elastic SAN, how to create and how to connect.
Adarsh and I are excited to share the latest Azure innovations to help you accelerate your SAN migration to the cloud. We're excited to announce a brand new product offering today, Azure Elastic SAN, to help your migration to cloud. It is a unique cloud-native and fully managed SAN-like block storage that our competitors simply do not offer. We will kick off with the introduction of Azure Elastic SAN. Why are we introducing this new service? Touching on the resources architecture and the capabilities it provides. Then we will talk about how we expect you to benefit from Azure Elastic SAN. What workloads or environment setup would best benefit most from Elastic SAN. Finally, we'll show you how to create your first Elastic SAN and connect it to your workload. We will begin by what is a SAN? SAN, short for Storage Area Network. It is a high-speed network that provides access to data storage at each levels. Multiple storage devices are connected to create a high-performance, low-latency, and scalable block storage. The introduction of SAN is to satisfy the need of growing storage footprint, independent of compute resources. In a hyper-convergent stack, you scale up storage and compute simultaneously. This typically leads to waste of CPU resources for data-intensive workloads that first saturate the storage pipeline. Then, SAN is introduced with FlashArray appliances, now commonly adopted by almost all enterprise customers in their on-premises data centers. SAN appliances comes in sizes of hundreds of terabytes or larger, millions of IOPS, and gigabytes of throughput. It offers competitive total cost of ownership in bulk purchasing model. It is widely adopted in on-premises data centers for hosting hyperscale databases, virtualization environments, VDI, virtual desktop infrastructures, and any IOPS-intensive applications. As we evolve our block storage offerings over years, we made significant improvements on the scale, performance, and cost efficiency of our disk offerings. However, we continue to hear from customers that it is quite challenging for migrating data stored in their SAN appliances on premises to cloud. Name few pain points. Starting with cost, existing block storage options offered by cloud providers always have a dedicated performance target per individual volume or storage unit. Resources cannot be shared across volumes. Comparing with on-premise SAN, the storage throughput that could be delivered by this single appliance is shared across all volumes. As all volumes sit on one storage box, the performance that a single SAN appliance can offer is shared. When you have a large enough pool of resources, you can balance it out the I/O spikes per individual volumes and maintain your I/O traffic at a very stable level. On cloud, you need to provision for the max throughput level you expect per volume to avoid potential bottlenecks in the system. Next, there is no single block storage offerings that works for different compute environments. With years, cloud providers have introduced various different compute options beyond virtual machines, with container solutions, VMware-hosted solutions, and more, while the cloud block storage options have been locked down for virtual machines only. As customers adopt cloud, they want to leverage different compute options for their workload, but have one consolidated block storage for simple management. Lastly, it's about migration. On a typical SAN appliance, you have hundreds or even thousands of volumes for different workloads. If the cloud migration journey requires the right sizing for every volume, it could easily take months of work. Even with migration assessment tools, it's quite hard to get it right at scale. To address these pain points and accelerate your SAN migration to cloud, we introduced Azure Elastic SAN, industry's first fully managed SAN offering in the cloud. Azure Elastic SAN supports a resource hierarchy just like on-premise SAN. You provision your resources on the SAN level, and that's where you get billed for. Then we have volume groups, which is nested below SAN, a grouping concept for applying security, networking, and data protection configurations. It maps well to the on-premises concept of network endpoint and data protection groups. Lastly, we have the volume, which is the same data storage unit as on-prem. Azure Elastic SAN enables customers to deploy, manage, and host workload on Azure with an end-to-end experience similar to on-prem and reduce adoption friction. You can provision storage on the SAN level and achieve massive scale in millions of IOPS and double-digit gigabytes per second. We are the first in cloud that pushes the scale limit to millions of IOPS on a single storage entity. By introducing the volume group concept, we simplify the volume management experience. It enables users to apply configuration changes on the group level, significantly reduce the management overhead. Lastly, we support data access to volume over iSCSI. It is a standard industry protocol, widely adopted for different workloads. Both Linux and Windows have inbox drivers that support connecting block storage over iSCSI. Azure Elastic SAN offers a differentiated solutions that no other cloud providers offer. It provides an alternative path for SAN migration that is driven by storage needs. If we put the user journey of creating an Azure Elastic SAN with on-premises SAN deployments side by side, we can see that Elastic SAN adopts a similar workflow. Beyond that, we overlay the benefit of cloud. Instead of waiting for a month to order a storage hardware, you could deploy and scale up an Elastic SAN with a few clicks on Azure. We also simplify the security and network configurations of your storage by introducing a management group as volume group. Any setting changes on the group level will directly trickle down to all volumes. With the introduction of Azure Elastic SAN, we extend our block storage portfolio to meet wherever your workload needs are. On the left, we have Azure Disks, our most optimized solution for virtual machines, ranging from standard HDDs to the fastest disk to UltraDisk. Then we have Azure Elastic SAN, the new product line to our block storage family. Azure Elastic SAN pushes the scalability target of cloud block storage. We will start public preview with 2 million IOPS, 32 gigabytes per second on the SAN level, with plans to increase it further in the upcoming releases. The provision target on SAN can be dynamically shared across volumes. Individual volumes can achieve 64,000 IOPS and 1,000 megabytes per second at a minimum deployment roughly at 100 gigabytes. So where do we think Azure Elastic SAN best fits? Ask these 3 questions to determine if Elastic SAN is the right solution for you. Do you want to consolidate your storage and achieve better cost efficiency at scale? Do you plan to leverage different compute options for different types of workloads beyond just virtual machines? Do you need to drive higher storage throughput for your workloads by leveraging network-attached storage? Put these questions in your mind as we share more details on the resource architecture and the capability of Azure Elastic SAN. Now, let's get into the resource overview. We will share the structure of the product and offered capabilities at each resource level. Azure Elastic SAN consists of 3 layers of resources. Elastic SAN, the top-level resource for provisioning and billing. Volume group, nested below Azure Elastic SAN, provide a similar grouping construct as resource group. Beyond that, you can apply configurations on the volume groups level that is enforced across all volumes. For example, network security rules. Then we have volumes, which are individual storage units where data gets written. Let's dive into the specific capabilities offered on each resource. When deploying an Elastic SAN, you start with provisioning workflow on the SAN level. We offer 2 provisioning units for you to compose your SAN, base unit and capacity-only units. They are designed to offer simple bulk provisioning experience while providing flexibility to grow your data footprint. Base unit gives you both capacity and provision performance, where capacity-only units allow you to pay for capacity only at a lower price point. It is important to note that provisioned resources on the SAN level is shared across all volume groups and volumes. Beyond the 2 provisioning units, we overlaid the redundancy option made available to meet your durability and availability requirements on storage. LRS, which is the local redundant with 3 replicas, and ZRS with synchronous replication across 3 zones. One base unit maps to 1 terabyte of storage capacity, 5,000 IOPS, and 80 Mbps at roughly 8 cents per gigabyte. One capacity-only unit maps to 1 terabyte of storage capacity, no provision performance, but at a lower price point, 6 cents per GB. Always refer to our pricing page for the exact pricing information. Let's look at an example on how you will provision an Elastic SAN. You have an on-premises SAN appliances of 250 terabyte, delivering 1 million IOPS, 16 gigabytes per second. You plan to migrate to Elastic SAN. You will choose LRS as 3 local replicas already provides better availability and durability than on-prem. You can provision a base unit of 200 terabyte, which gives you your target of 1 million IOPS and 16 gigabytes per second. Next, you can meet the rest of your capacity needs by provisioning 50 terabytes on capacity-only unit. Now you can reach the target of 250 terabyte without the extra cost of provisioning more performance. The next layer is the volume group. Storage administrators can use volume group as a container for volumes that serve one target workload. Then apply encryption network security settings on the group, which gets trickled down to all volumes in that group. A SAN can have up to 20 volume groups. We will talk about how to configure network security rules to grant data access over the network as an example. In public preview, we leverage network security rules to lock down client access to volumes. By default, all network access to volumes under a volume group is denied. So you don't run into the risk of deploying volumes that are open to public access. You can configure network security rules to grant clients from a specific virtual network access to the group. For instance, your volume are deployed for an AKS cluster. You can add a rule to unblock network access from the virtual network AKS is deployed in. Then all clients from this virtual network can connect to any volumes in the group over iSCSI. If you're familiar with the network security settings on Azure Storage account, this is similar to enabling your account for public network access from selected virtual network. This is required step to unblock iSCSI connection to a volume. Volume is the actual storage unit where you read and write data. We support data access to volume over iSCSI protocol. iSCSI protocol is widely adopted. Both Windows and Linux have inbox drivers to initialize connections to an iSCSI target. The performance of a volume scales linearly with capacity. However, we designed the scaling factors to be so high that you really don't need to worry about the performance. You can achieve the max performance target of 64,000 IOPS and 1 gigabits per second at around 100 GB. All volumes will share the provision performance on the SAN level, but you don't need to provision the SAN level target to fully match the sum of all volumes. For instance, you can have 500,000 IOPS provisioned on the SAN level, then deploy 10 1 terabyte volume where each can reach a maximum of 64,000 IOPS. Though the total of all volumes max IOPS reaches 640,000 IOPS, you don't have to fully provision that on the SAN, as you don't expect that all volumes will reach max target at the same time. By now, you would have a good understanding of Elastic SAN and cannot wait to get your hands dirty. Let me turn it to Adarsh to show you how to create an Azure Elastic SAN. Now, let's see how we set up this resource.
Thank you, Yumin. So, before I jump into the demo, I wanted to walk you guys through this workflow. As you can see here, we have the entire workflow for how to create an Elastic SAN underneath with a lot of the parameters that you need in order to provision it underneath each section. So resources are provisioned on the SAN level. So when you fill out this information, you should make sure that you know exactly what kind of workloads you want to host, and then figure out the respective capacity and performance requirements. Once you have this information, you can provision storage and performance accordingly. The workflow is basically as follows. You create the SAN, you create the volume groups, and then you create the volumes. I will now show you guys exactly how to do this. So we start off with the project details. You pick the subscription you want the SAN to fall under, as well as the resource group. We then move on to the instance details, where we enter the SAN name. We see that we can select the region. I've selected East to ES2 stage. We then move on to the other fields. We have LRS and ZRS. I selected LRS. And then we have the zones. I just picked zone 1. And in terms of performance, we only offer 1 tier as of now. Moving on to the actual resource provisioning portion of this, you enter the base and the additional capacity. And as you can see to the right-hand side, the IOPS and bandwidth are provisioned based off of the selected base capacity. So moving on to the volume groups played. We create the volume group. There is only one thing that you can fill in here as of now, and you can't change the volume group name after creation. That is an important thing to note. So you've got the volume group, you've got the protocol type, and you've got the encryption type. We then move on to the volumes blade. In terms of the volumes blade, we fill out the volume name, we fill out the volume group information, that is the volume group that we want the volume to fall under, and then we also fill out the volume size in gigabytes. You can see the provisioned max IOPS and bandwidth of the volume. We then move on to the tags page, where you can add whatever tags you desire. After that, we move on to the review plus create page, where we finally can review our selections, make sure that we think everything is correct. If you've misspelled a SAN name, a volume group name, or a volume name, now is your chance to go back and edit it. We then click on create if we decide that everything looks good to us. And then we wait for the deployment to complete. And there you have it. Deployment succeeded. I'll now throw it back to you, Yumin, to talk about some customer scenarios.
Next, we would like to take a look at a few scenarios where Elastic SAN will be a great fit. Because Azure Elastic SAN uses a similar resource hierarchy to on-premises SAN, you get the same consolidated experience that makes management easier. Network and encryption configurations are set at the volume group level, but applies to all volumes in that group. Beyond the simpler management experience, you can achieve better cost efficiency by deploying block storage at scale. We let you share the provision performance of your Elastic SAN across these volumes. You can easily achieve high performance with great cost efficiency. For example, you can deploy a 100 terabyte SAN, which will give you 500,000 IOPS. These IOPS can be shared dynamically across 101 terabyte volumes, where each volume can hit a maximum of 64,000 IOPS. So the larger sample you have, the better efficiency you can achieve, since you can access the available performance from whichever volume needs it. Also, if your workload requires more storage than you originally provisioned, Azure Elastic SAN offers capacity units that provide only storage. So if you need an extra 20 terabyte, you can purchase just that at a significantly lower price than you had to purchase with more performance. Azure Elastic SAN supports industry-standard iSCSI protocol, allowing it to connect to a variety of Azure compute options, like virtual machines, containers, and more options on the roadmap. So even when you are running workloads on non-VM-based environment, Azure Elastic SAN allows you to lift and shift your SAN workloads to the cloud. Talking about workloads, when you have a workload that requires high throughput, you might run into limits of the disk throughput on your VM. For example, say you're using Azure Standard E104 v5 VM, which is capped at 120,000 IOPS and 4,000 megabytes per second. Now, for your quarter-end reporting, you need very high throughput to complete the data processing in time. With Azure Elastic SAN, you can drive throughput over VM network bandwidth which is not limited on IOPS, and where your throughput can go as high as 100,000 megabits per second, giving you an additional of 12,500 megabytes per second throughput over the wire. So how do you connect to a volume in Elastic-SAN and best leverage its power? I will turn it to Adarsh, who will be showing you an example of how we connect to a volume from a virtual machine.
Thank you, Yumin. So like before, guys, here we have the workflow, and then I'll show you guys the demo after I talk you guys through this. So we start off by setting up VNet ACLs. So you need to set these up by adding a VNet to your volume group. As Yumin mentioned before, access to volumes is restricted by virtual network access rules. These can be set up during the creation of a volume group or by updating a volume group. We then log into the VM, we call the getVolume API, and we generate iSCSI commands based off of these parameters that I've detailed here, and I'll give you guys a little bit more context on that during the demo. We then run the iSCSI commands that we've generated, and voila, your volume should be connected. For reference, volumes on Elastic-SAN need to be connected via iSCSI protocol, need to be accessed via iSCSI protocol, and you need to use the IQN, the iSCSI qualified name, to gain this access. So moving on to the actual demo. As you can see, I start off by calling the getVolume API. We're going to be pulling out the storage target IQN, the storage target portal hostname, and the port itself. We will be using these three parameters to generate our iSCSI commands. So we have two iSCSI commands that we're going to need to run. The first is the iSCSI add target command. As you can see, I've run that and the operation has completed successfully. And then the second command that you'd need to run is the iSCSI login target command, which I will be running for you guys shortly. There we go. So as you can see, we have a session ID, we have a connection ID, and we can see that the operation has been completed successfully. Now, moving on to the disk management blade that we see here, there is now a disk on this blade that did not exist before. So this is how we know that the volume has been connected. You can't just use it directly. You'll need to initialize it and set it up, but the hard part's over and you've connected your volume. I'll now hand it back off to you, Yumin, to talk about the product roadmap.
Thanks, Adarsh. What you heard from me today is just the preview capability of this new Elastic-SAN offering. We have more enhancements to come. We'll unblock new use cases supporting integration with more compute options. We'll further extend the scalability and performance target of Elastic-SAN on IOPS, megabytes per second, and capacity, while reducing on latency. We will enhance our service management and security capabilities by offering SCSI PR support, server-side encryption with customer managed key, and enable private endpoint support. Lastly, a storage solution is not complete without proper backup and disaster recovery. We will soon add incremental snapshots for fast backup and recovery, along with snapshot export for hardening. We encourage all of you to try out Azure Elastic-SAN and share with us your experience. Here are some useful links, including the preview sign-up form. Adarsh and I hope you find this session helpful, and we look forward to seeing you trying out Azure Elastic-SAN.
Thank you, Yumin, and thanks to all of you guys for joining us as well. I hope you guys learned something from this. Have a great rest of the day.